Hello guys, welcome. In today's video, we are going to talk from chapter number 1, Euclid division lemma. We are going to start with chapter number 1 in one of the basic concepts and one of the most important concept in whole mathematics, okay, is Euclid division lemma. So let us understand what does it mean, how the question is asked in exam, everything we need to know about Euclid division lemma I'm going to explain in this video. So it is from chapter number 1, number system. So let's see Euclid division lemma. Let us understand first. After that I'll give you the statement of Euclid division lemma. So let us understand what does it mean by Euclid division lemma. Take any two number. Okay, take any two number. Suppose the number are, let me change the pen, let me take a little bit thicker pen so that it will be easy for you. So let's take any number. So numbers are 8 and 20. Suppose let us take any two number. Then suppose let's divide this number 20 by 8. Okay, let's see. 8 1 8 8 to the 16, 8 to the 16, remainder is 4. So I'm going to tell something that all of you know, okay, and if you don't know, listen very carefully. Okay, then here this 4 is remainder. Okay, this is called remainder. So let us represent remainder by r. We can write any number, but let us write r, okay, because we are going to understand why I'm writing r. Okay, another is here 2 is called quotient, quotient, quotient. Let us represent this by q. Okay, now we know that 20 is dividend, you know, right? If you don't know, please note it down, dividend, right? And let us represent dividend by a. Okay, simple, we are representing that dividend by a. Okay, here in this particular question, dividend a, that is 20. Okay, 8, we can represent 8 by, now first what is 8 called? It is divisor, right? This is divisor. So let us represent divisor by b. Okay, here divisor is 8 and we are representing it by b. Okay, then I'm going to tell something that you know already. Okay, then we can write this whole thing, we can make this as an equation. We can write dividend, that is, suppose we need to find dividend, is dividend, I don't know, I think it's d here. Okay, dividend is equal to divisor into quotient plus remainder. I hope you know this, right? This is quite simple mathematics, simple division. Okay, simple division. Now if you don't believe that dividend is equal to divisor into quotient plus remainder, I am going to prove for those students who are having doubt in this equation. Divisor here is 8, right, into quotient. What is quotient here? 2, right, plus remainder 4, right? 8 to the 16 plus 4, 20, right? 20 is equal to dividend, right? Dividend is 20, so hence proved. Okay, clear? Okay, you don't have any doubt in this. Okay, now how does it related to Euclid division lemma? Okay, I'm just explaining you the basic division. Everyone knows this division, so you must be thinking how it is equivalent, how it is related to Euclid division lemma. Let's see the statement of Euclid division lemma. Okay, let us see. I know every time. Let's see. State Euclid division lemma. It was asked in 2016, if I'm not wrong. One question paper I saw, it was asked in 2016. I think in the coming days I'm going to share you the question paper. Even if you don't have the hard copy of it, I'm going to share the PDF format of the question paper. Okay, in coming days. Okay, and now state Euclid division lemma. It was asked in 2016 by giving 1 mark. So am I making this video just for 1 mark? Yes, and even more than that. This Euclid division lemma is very useful in solving exercise 1.1, and even it is very useful while you do calculations with polynomial 7 chapter number 2. When you are dealing with all those things, it is very important, and it is, if not asked, or it is not asked in any other question also, this concept is very important. Okay, it's basic concept and it is very important concept. So let's see this. Okay, state Euclid division lemma. Let a and b be any two integers. A and b are any two integers and b is greater than 0. Okay, I can understand that. Then there exists unique integer q and r such that a is equal to bq plus r, and r is greater than or equal to 0, is less than b. This is the statement you are going to write in exam to get 1 mark. Okay, so let us understand what does it mean by this. Okay, let me change the pencil or pen, tell anything. Okay, now let me explain you the concept. Okay, now a and b here, a and b are any two integers. What are integers? Integers, the numbers, negative numbers, zeros and positive number, all these are integers. -2, it's an integer. 0, it's an integer. 2 is an integer. 5 is an integer. Any number, negative, positive and 0, all these are integers. Clear, right? So a and b are any two integers. It can be negative or positive or 0 number. Okay, provided b is greater than 0. Okay, b doesn't equal to 0 actually. The concept here, b is greater than 0. B must be greater than 0. It must not be 0. Okay, it must be greater than 0. Then there exists unique integer q and r such that a is equal to bq plus r and then 0. This concept. Now I hope you understand till here. Then there exists unique integer q and r such that a is equal to bq plus r. This concept, if a was dividend for us, is it? And b is divisor, q is quotient and r is remainder. So this is the concept. Dividend is equal to divisor into quotient plus remainder. We have seen before. Okay, let me show you the page. This one, dividend is equal to divisor into quotient plus remainder. If you happen to represent dividend by a, I'm writing a here, and divisor is b and quotient is q and remainder is r. We got this equation, right? So this equation came from simple division. Okay, now let's understand another. Now suppose here, if we happen to divide any number, okay, any number, suppose let's say here we divide 8, divisor is 8 here. Suppose if divisor is 8, can the remainder be greater than 8? Can the remainder be greater than 8? Never, is it? Can it be equal to 8? It cannot be. Divisor, this divisor, okay, remainder, okay, here remainder 4. Remainder may be, suppose let's say we happen to divide 23 by 8. 8 to the 16. Remainder is 4, 5, 6, 7, right? Remainder is 7. Suppose we happen to divide by 24. 8 to the 16. Remainder is 8. Wrong calculation. We have to do 8 3 24, right? Remainder is 0. So it can be 0, it can be 1, it can be 2, it can be 3, 4, 5, 6, 7, but it cannot be 8, right? So we can write this statement. The idea here, we can write the idea is remainder is can be greater than equal to 0, less than 8 for this 8 divisor, right? So in general concept, in general formula, we can write like this: is it 0 greater than 0 and less than remainder b. Here b, this is b. In that example we have taken b as 8. It can be any integer as given in the question. B and a and b are any two integers. Any integer, take any integer, this will be true. So you understand the concept, is it? This is very important concept. If you just take the screenshot of this question, you can take the screenshot, or it can be available in page number 2, theorem number 1.1, page number 2 and theorem number 1.1. If I'm not wrong, let me check it out. Yes, that's correct. Theorem number 1.1. There is the statement. You can copy that, or you can understand and you can learn, understand. Don't memorize it, okay? Don't memorize it. You'll understand that because I've explained to you. Okay, thank you so much. We'll meet in the next video with another great concept from the same subject. Thank you so much.